Actually we're comparing the various equivalents in AWS, Azure, and GCP. I think we started we started with the primarily machine learning in the last session. I think there are one more slide which we need to complete in the machine learning side. Um, and then we'll go to the IoT space comparing the three. I think with that we can logically conclude this comparison study. So I think just to brief up, I think on the machine learning side, I think the last session we looked at the life cycle, the typical life cycle of a machine learning, and also what are the tools around that space. And I think we looked at uh, the flagship products, SageMaker in the AWS, Azure Machine Learning, and GCP is AI Hub. This is these are the flagship products. Under that, most of the sub products, all the other products which will probably come under the base umbrella of this flagship products. So yeah, primarily, there will be training. There will be tools where primarily these flagship products will take care of end-to-end machine learning implementations. Wherever required, they plug the respective sub-products under this category. But overall, they govern the entire AI and machine learning landscape. So this includes starting from training, deployment, automation, and managing the ML models. So yeah, this is what these products will primarily take care. But if we see the machine learning and AI and machine learning space is quite broad. So we have it depends. I mean, especially in this side, we need to pick a area. I think it is. I mean, it can be of course, if you're an expert, yeah, you can involve in all. But generally, it depends on the area that you work. So you have to pick an area where either you should be coming under the products development or primarily, especially you are looking in the text analytics or speech analytics or voice analytics or image detection. So there are a lot of variations are there. So based on that, there are specific products are also there. Probably this is one space where it requires some consolidation because a lot of places, I mean, a lot of products are there in this landscape, even in IoT space also. So because it is because it is very diverse area. So in this yeah, I think if you go further, I think based on it's continuing on what we discussed last time, it is the intelligent bots category. I think there are tools like Alexa skill set in AWS. Alexa is their other flagship IoT product, and Alexa skill set is where you develop more skills, and it's more of development of skills or apps around Alexa skills. So and bot framework for Azure, and GCP is Dialogflow. So coming to the speech, like the speech is a lot of combinations like speech to text, text to speech, and also the natural language understanding, and also making the dictation or converting live the audio that you receive, converting that to text. So a lot of variations in that. So in this space, we have tools like especially converting the speech to text category, and also understanding your unique vocabularies and make our speaking styles and understand that, and then converting the data from speech to text. In that category, we have Lex in AWS, cognitive services, speech to text in Azure, and AI building block conversation, and natural language understanding category to like converting them to apps, bots, etc. Again, Lex in Azure, it is cognitive services. Luis is also a very popular product, which is I think getting a lot of traction these days. And in GCP side, it is AI building blocks language. If you look at on the GCP side, mostly there are a lot of names changed in the recent past. I think probably this is probably the final convention that probably they concluded, because the old names, I mean, you see a lot of content. The older names were used, but I think they're now logically renamed. But I think the new name in the GCP world is AI building blocks, because they logically categorized all the products under this building blocks of AI building blocks conversation, AI building blocks language, and AI building blocks site, and AI building blocks structured data. So likewise, it is from the name itself we can understand what it does. So that's why it is more logical in that way. Yeah, but at least yeah, when you search for these products, you might refer the old names also. But yeah, but these are the new names that we have now. Um, so yeah, anyway, so this language understanding to apps, yeah, Lex cognitive services and language and speech to text category, AWS Poly and transcribe. So especially transcribe is used especially for medical industry more. So like you can as a doctors will talk, then there will be some medical practitioner who will transcribe the content. That will be kind of more replacing that person. So it is more used in the medical industry especially. And in Azure, it is cognitive services, text analytics, and speech services. Yeah, the equivalent is languages again here. So that's about the speech to text and text to speech category of blocks. And next is the video. So like computer vision. So computer vision space is more. You need a camera, or some device which can capture the image or the video. So based on that, you can make some predictions or making the data more smarter kind of a concept. So in this category of computer vision category, so the computer vision face detection emotions in that category, AWS recognition, REK is the name here, the recognition, and Azure it is cognitive services computer vision, and GCP it is AI building block site. And next is like empower the data scientists with to build machine learning models more rapidly. Meaning it is not possible for especially for smaller organizations or who are not into who have very small budgets on the IT side. It is difficult to have a data scientist or a pool of data scientists. So for that space to replace a human in the data, or reduce the involvement of data scientists for smaller use cases. So they're and more of empowering the data scientists to quickly build models in either category. So in that category, so in AWS we have SageMaker and Autopilot, uh, and in Azure it is automated machine learning, and in GCP it is AI building block structured data. So these tools will help you to primarily with minimal data scientists, you can using this auto category. I mean, it can auto generate your models or auto train your data based on the content. So or auto detection of any based on the inputs that you provide, looking at the image. So it does most of it automatically. So kind of it is replacing. Yeah, you need to upfront invest a data scientist into your organization, because the auto will solve most of the common use cases. So in that category, this automatic yeah, the machine learning tools are also there, which is getting popular these days. The autopilot, automated ML and structured data, and in yeah in this category of visual interface, like easy to understanding the visual interface, and from that trying to build a custom machine learning models. So I mean, most of them is this is, if you see here, this is auto building a model with auto configurations. But most of this may not be suiting for all the use cases. You might have to build a custom models, which is a very common use case. So in that case of building a custom machine learning model, so the tools that we have in that category are AWS SageMaker, Azure it is ML.NET Model Builder, and GCP it is AI Building Block Structured Data. So again, getting the insights from the videos, like identifying a person or identifying a particular scene in a longer video. So in that category, AWS recognition, and Azure it is video indexer, and GCP it is cloud auto ML. Now just be familiar with the names. I mean, I know it is too many products in this category, but I think but as an architect, we should also know what or at least be familiar with the names, so that when scenario comes, it will be easier for you to quickly get into the product and go deep dive. Yeah, and there are some. This is again the news area which is getting popular. I mean, the earlier is just a bot development was the initial everything was chatbot was a prominent area in the last. For example, in this category, chatbot building a chatbot is very popular use case that was quickly applied in most of the industries. But I think the pain point in that is training that bot. So the bot is development is easier, but only thing is making the bot more intelligent. So that was a pain point. So or how to train that bot to intelligently answer a question when someone asks. So that was a pain point, and that was addressed with this category where auto learning. So auto learning of a bot. So basically, most of the websites or products. So they also already have FAQ pages, product manuals, and websites. So, so instead of you giving all the details, bot if you give just the links, and bot can quickly read it and understand it just like a human. So that category, the training a bot in that category is what is this sub products. AWS chatbot, Lex and Kendra. Uh, Azure it is cognitive services Q&A maker. Uh, in GCP it is Cloud Auto ML. So so that's about the bot learning on its own. And next is the category for a developer. In developer, it is also equally important that we should have developer tools also in this ML, auto ML areas, also AML areas. So in that category, Jupyter notebooks are quite popular because most of the machine learning implementations are based on Python. Python is most commonly used programming language for machine learning. So Jupyter is a notebook kind of a feature. It's like a wiki page for all your AI machine learning models, where you can write small. It can understand Python. It's a Python compiler behind the scenes, and it has you can write Python code, and also it also has integration to depict the output in the form of graphs, and also it can share the notebooks to others. So it is more about the collaboration for machine learning between developers. So in that category, the Jupyter notebooks, which is helping a developer to develop quickly, share quickly, and get feedback. So in that category, AWS has a tool called SageMaker Jupyter Notebook, um, and Azure has Azure Notebooks, and GCP it is AI Platform Notebooks. So
Sam,
yeah,
one
yeah,
question.
yes.
Sorry, like I missed it last week. I think you gave an intro. This Jupyter kind of strikes a particular thing. Is it like basically what do you call a container that they're giving for developers, or what is it?
Yeah, it is container at the end, but
Mm.
the I mean the output, if you are to see, it is a wiki page where you can write. I mean, then it is a compiler of a Python compiler in a form of a wiki page. So if wiki can understand
Mm.
your Python code, so you can write documentation there, you can write code there. It can see
Mm.
the graphs of the Python GUI libraries. So yeah,
Yeah.
so
So all these notebooks, they all for the open source notebook, right? It's called IPython. Interact. It's using something called the interactive Python model. Basically, instead of using an IDE, you just compile and run it. Here, you have sections in the web page. Your so it's all web page based tool. It has horizontally it is kind of partitioned so that you could run your one of the section, it will show the output in the same web page, and then whatever the variables you declare in that section, you could reuse it in the next section. So that the reason is for cleansing the data, correct? You have so much data and you want to see the data, understand the data before you do whatever you want to do. So this interactive Python is an open source concept, very popular. You don't need to have any of these cloud providers to use it. But these cloud providers, they knew the benefit of that, and they said, okay, I will integrate with my product called SageMaker, so that you get the same IPython interface, but you will be interacting with the SageMaker behind the scene and get the things back from it.
Yeah, so because this is one of the things that we had a lunch and learn session, I think, like in RBC, like basically,
Uh,
means all the quants guys, right? Like they are using Python, right? Like to model
yeah,
a lot of things, actually, right? Like so,
yeah.
this is one of the things they are bringing in. But
Ve-
so,
Yeah, it's very
mm,
popular, man. This is actually that is what one of the, if you think about Java and Python, right? Both were neck to neck. This is one of the features of the Python which took them to the next level, because now you don't need to have a separate programming and coming out with the UI. In Java, to come out with the UI, you have to write your own UI, and then here in the development tool itself, you just try to put your program and it will render it and immediately show it to you, and you can get those variables and keep on decorating. It's using the decorator pattern. um, yeah, one of the big challenges, now there are so many data available, structured, unstructured, even non-structured data like a video and audio. This IPython interface is one common medium where you could able to visualize all of them, so that when you visualize, you can do better programming. Because when you want to massage the data, you have to see the data how it is. That is where the IPython is very popular.
Yeah, I think this is a sample output that you're seeing here. For example, this is a Python. I mean, I just opened a Jupyter lab where online. I mean, I'm just in the lab itself. I'm opening a Python notebook. This is a sample Python notebook, for example. So PY, so if you see here, it has document just like a wiki page. It has documentation like this, and also it has editor, inbuilt Python editor. This is a Python editor. So matplotlib is one of the libraries of Python, so which is being used for mathematical operations. So it is a Python code that what you're seeing here. So you can get the outputs like this in a screen. So it's a mix of documentation plus compiler or Python code editor inbuilt. So yeah, so, and you can also generate a documentation also like this. So it is if you're not interested to see this, but you can generate a HTML page output also like this. It is very popular in the machine learning space. Yeah, you can share this to anyone to, or you can upload files, download files, and you can use like online editor IDE itself. Yeah,
mhm.
and yeah, that's because it is
Yeah,
more popular.
more popular on the data science itself. Yeah, whether you use machine learning or not, people, if they want to see the data in a diverse way, this is the best way to do. They have to cleanse the data to make sense.
Yeah, so because it become so popular in this Python machine learning side, I think every cloud provider integrated that. It is, and by the way, the old name is what Srini said is IPython. That was now renamed to Jupyter. So yeah, so this is now integrate. It has an integration to all cloud vendors, so that you can see the popularity of it. So um, and yeah, so again going
No
for
standalone version, is it? No standalone version. Like so, suppose
Yeah,
you.
yeah, it
ah,
is
yeah,
open source is there,
open,
man.
it's an open
No, no,
source.
no.
It's an open
I
source solution.
go for IPython. Yeah, when you download the whole Python package, right? Anaconda, when you download your whole package, you get that also for free nowadays.
Yeah, this
So
is the site.
Mm,
this IPython is there for everybody who has, it's an open source. But all these cloud providers, they just put the paint on it.
Mm. You get fancy graphs also like this. You can get all the standard graphs and other things. Yeah. So yes,
okay,
going.
sorry. Yeah, I took a diversion. Okay,
No problem.
right.
Yeah. So then next is the category of yeah, I mean pre-configured environments. So I think setting up this AML space itself is a is a lot of effort. Like you need generally, it depends on the area of machine learning that you work, but generally a lot of libraries and pre-configuration is required to set up or get started on setting up this environment. So for that, to avoid wasting time on that, so there is a lot of pre-configured environments, so where you can get started by just using those pre-configured environments. So you need to do waste time in setting up all the environment for you to start the development. So in that category, in AWS deep learning AMI stands for machine image. So it is just like an image of all the required libraries installed, and you can just download that into your EC2. Then you get all your deep learning images ready for you to get started. So you can use this AMI deep learning AMI. You can import that into your EC2. And you have EC2 machine with all the deep learning libraries pre-installed. And also, if you're interested in containers, then deep learning containers also an AMI that you can containers that you can use. And Azure, it is data science virtual machines. So yeah, there it is EC2. Here it is virtual machine. So data science virtual machines in the Azure. So it has all pre-configured setup for all the data science requirements. In GCP, it is deep learning VM image. And GPUs is, I mean, the CPU is for smaller workload, but generally these machine learning workloads, it depends on the type of data it has to be, it has to crunch to generate a model. So sometimes this training will take a lot of time because it depends on the data that you are giving it. So sometimes for a smaller use cases, it can even go to 1 week to get a model, or output of a training is a model. So that model will take at least it will take a lot of time to get the output. So for that, in case let's say if you're interested to get the output faster, so you can use especially when you're dealing with videos or images, when especially your data is not in structured format, it's like the unstructured format. So you need a higher CPU power to consume or crunch the videos or images. So for that, the CPU may not be sufficient. A GPU will give you more power. So the GPU is called graphical processing unit for especially for compute intensive workloads. So in that category, so in AWS we have tools like deep learning on GPU instances. So this is primarily it comes in the deep learning category where you are actually crunching a non or semi-structured or non-structured unstructured data. So there you especially you need more power. So yeah, so you have special instances like GPU instances, not CPU. It is GPU. GPU instances is where what you get for and especially it is configured for deep learning. And in Azure it is GPU support on AKS. Stands for again Azure Kubernetes Services. So GPU support on Azure Kubernetes. Then GCP, it is deep learning containers. So then the next is the data labeling category. I think we discussed in the last week about the life cycle of a machine learning. So in that one of the stage is like training training the data or gathering the data, and in this process of gathering the data and giving the input for training, you should also in the process you should also label the data. So that way, a metadata of the data is already there. So that way, we know. For example, I'm just giving an image. There is a processing the images of a cat, and especially in one of the image you see a tail or a leg. So you can add that metadata into the input image by using data labeling. So that way, when the same data is getting processed again, which is very common in machine learning, the same data when it's getting processed, so it will not waste time because it is already labeled. So it will use the label. So it will make use of the label rather than crunching the data again. So that way it helps in your training the process faster. So in that category, this data labeling is a new trend that is getting popular, and yeah, so which will save time in the training the data. So um, I think what I hear, one of the pain point in this AML category is training the data. Especially first is like data preparation and then training. So these are the two areas where most of the AI machine learning guys will spend time, because um, that is the input, right, for your output, which is a model. So unless the input is clean, you will not get a clean output. So yeah, so whatever, so there are tools evolving to make your training faster. So in that category, all these tools are coming under this GPU or data labeling category or training service. The next one, yeah. Yeah, so coming to data labeling category, so AWS SageMaker Ground Truth. So this is one of the tool which helps in the data labeling category. In Azure, it is Azure ML data labeling. In GCP, it is data labeling service. Next is training the services, especially when you do a training of the data. So you encounter a lot of issues where you're let's say you're crunching 1 week data. You have so much of data, and it is running for 1 week to get the output. Let's say in between you have a network issue, or a node is down. So it has to manage the training should start from again, right? So it should start from where it got interrupted. So it should automatically adjust its surroundings and start from where it was left. So in that category of making again that managing this training better with the proper compute management. So compute is one of the area where generally the issues will happen there in compute or networking. So to manage this in a better way, so we have some tools around this. So AWS SageMaker distributed training. So by distributed, because the computers that you use are like common EC2 nodes. The EC2 nodes will be different nodes will be coming together to make your job. So yeah, so it is you'll face a lot of issues when you're dealing with distributed nodes. Any node can go down and other things. So yeah, so to manage that in a better way, so yeah, this AWS has tools like SageMaker distributed training. When you see here, everything is SageMaker more or less, because SageMaker is their flagship product. Under that, there are sub products. All of this like SageMaker distributed training. Here is Azure ML. Azure ML compute targets, managing these computes in a better way for training, and GCP, it is AI platform training. I think the last set, I guess, yeah, last set, yes. I think this till here we saw in the last week. I think this is a fresh set which I added. So in this deploying your model, what we saw earlier is training. Now let's say you completed training and you got some model. So the model is generally the first model that you get may not be a super duper one, which may not fit. So it's a continuous process. So you should every day you get more data in the input, and also your output also should consume that newer input that you get every day. So every day you are running the training models and making it better, making it better, making it better. So so once you get the output, which is a model, so managing the model, is your model right? Uh, these are the very common questions that you have when you get output, but you get a model. Now the questions that you get is how will you manage this model? Today you got one model, tomorrow you get another model. How will you deploy your models? And you get some inference out of a model, and how will you validate which version of your model was used to get this inference. So these are the very common problems in day-to-day life. So to handle those problems, so especially deploying your various ML models and model inferences, so managing your ML model in production. So that is where this tools will come. So AWS SageMaker pipelines and inference pipeline. So it is, you can imagine that CI/CD for machine learning. So you have a pipeline, Jenkins or something equivalent CI/CD pipeline that you have. So imagine the same thing for machine learning. I mean, the CI/CD is now in AML. There is a new trend which is starting called CT, continuous training. So it's continuous integration, continuous deployment, continuous training. The CT is what is added in this new versions. So yeah, CI, CD, CT, continuous training. So in this CT category, so the SageMaker pipelines and inference pipelines will help you. And in Azure, it is Azure ML deployments. In GCP, it is AI platform predictions. So yeah, so next category is drift monitoring. Drift is a very common keyword in the machine learning space. Once you get a model, the model may not be 100% right. And generally, what they do is the output that you get, they compare it with the actuals and see what is the drift. Drift is like difference. What is the delta? It didn't do well. So probably the predictions from the ML probably is it 70% accurate or 80% accurate or 90% accurate, for example. So what is the delta or drift? So monitoring the drift is like comparing with actuals and identifying what is the delta. So that is what is called drift. So the data drift monitoring is one of the very common pain points in this machine learning space. So in that category, so AWS SageMaker Model Monitor and Azure as Azure ML Data Drift, and GCP it is continuous evaluation. So yeah, you can see that from the name here, GCP is obvious. So it's continuous evaluation. You're comparing with actual and see you're evaluating your model. So that's where you can calculate the drift. So and see whether is the drift. Generally, in ideal case the drift should be almost zero, which may not be a case. It's not possible 100%, but drift should be zero in ideal case. So which means your model is perfect. But there will be always a drift, and it's a continuous process. Like you have to since the training is also continuous, your model that you get is also continuous, and your drift is also will be changing every day. So yeah, next is uh, ensuring the ML model compliance with company policies and industrial regulations. So this is a very new category that was introduced. Okay, you got an ML model, but and these ML models are now getting industry specific. So how to manage our compliance or ensure that it is regulated. For auto industry, for example, if you have a ML model for a auto industry or a finance industry, how will you regulate and what are the company policies that you should be compliant for that model? So those are areas like generally, well, these are all once a product is live and it is doing a good job, then all these regulations will come into picture. So how will you handle that with the ML model? Is what is this another pain point? So to address that, I think AWS has SageMaker Clarify and AWS Feature Store. So it's like app store, right, in mobile. So now it is yeah, ML model feature store is the next store of all your models. Like storing all your ML models in a repository like GitHub, where you source the source code. Now ML models, which are open source ML models, are being kind of published into a store. Yeah, all these are private stores, but I think the public stores are also getting popular. Yeah, so SageMaker Clarify and Feature Store, and for AWS and Azure, it is Azure ML model interoperability. In GCP, it is What If 2. So yeah, and again now you're running the models and you want to run the models more faster to get the outputs or training you want to make it faster. So then the hardware plays a major role also in this process. So what all these cloud vendors realized is that okay, software is one set, but also we can improve our running the models or training can make it faster even with hardware or improving the hardwares. The hardware improvement is also getting a lot of popularity now, especially for machine learning. So machine learning specific hardwares are coming out. So in that category, AWS has EC2, this is a virtual machine like EC2 F1 FPGA instances, and also chips, AWS Inferentia chips. So these are all again chips and hardware specific for machine learning. Again, here Azure, it is Azure ML FPGA. By the way, FPGA stands for Field Programmable Gate Arrays. So, so in this, it is more, it's just handling your ML model, making it more faster and program. Just like imagine that it's like a microcontroller. You can coming with a better microcontroller, which is meant for machine learning. So for in that category, so this a lot of innovations are happening in this space because software can be done only to some extent. I think if you want to improve your turnarounds on this training, so yeah, hardware and compute, especially compute space, is going under a lot of innovation. So yeah, so that is one area. And this in GCP, it is cloud TPU. TPU stands for Tensor Processing Unit. So TensorFlow, we all know, right? I think TensorFlow has become so popular, and Google introduced this name called TPU, Tensor Processing Unit, like CPU, GPU, and now it is TPU, Tensor Processing Unit. So this is TPUs are machine learning specific hardware where it can, I mean, it's compute category of compute hardware especially. So where it can crunch petabytes of data at a very faster rate, and so that way your turnaround times on training can be done faster. So yeah, and next is MLOps. MLOps is like DevOps. Now there's MLOps is also getting a lot of popularity now. How will you manage? I mean, DevOps we all know. So it is development and operations put together. Is like how a developer and operator who manages your software in production. So if they both come together, is DevOps, right? So similarly, in ML developer and ML operator coming together is MLOps. So primarily, you can say that MLOps is equal to DevOps for ML. So so in that category, again, the problem statement is same. How will you manage how ML developer and ML operator can manage the ML software? So so in this category, you're generally you manage, deploy, monitor, govern your ML models. So in that category, AWS has SageMaker pipelines and model monitor. So I mean, monitoring is very important area in this ML because you need to know how once your ML application is live, is in production. So then you need to monitor how it is performing. So at the same time, you need to have some CI/CD pipelines equivalents to deploy and manage your ML models. So yeah, so in this category, we have operations should have some tooling. So that is called primarily an operation tool, MLOps tooling. So in Azure, it is ML operations, and in GCP, it is Kubeflow. Kubeflow is again, Ashini is already working on this, saying that has worked on this Kubeflow also. But I think it is more Kubernetes specific tooling, and GCP is embracing Kubernetes for machine learning. So yeah, so Kubeflow is meant primarily for machine learning. I can say machine learning Kubernetes is Kubeflow.
So one thing is, since Kubernetes is getting de facto now, So Kubernetes managing the machine learning is also a paradigm. So even though SageMaker, AWS is trying to promote, they cannot be that successful because of the prominence of the Kubernetes. Kubernetes, people want to architecture standardizing for any compute related things. It wants to go to the raw, the Kubernetes compute way. That means machine learning is also coming under that compute. And the Kubeflow, even though it's GCP, it is also, whatever the GCP comes out with, it's all open sourced as well. So you could run the Kubeflow in the EKS, the AWS EKS Kubernetes also. You could run the Kubeflow without any problem. So there's a huge competition going on, like whether, I don't think anybody can change the Kubernetes thing. That is going to be the de facto for compute. But for the machine learning, these guys can have their own flavor, or that's also be Kubernetes is what the thing looks like. It is going towards Kubernetes on that also.
Yeah. I think Kubernetes is, yeah, and since it's already popular in the other area now, AI and machine learning also now embracing Kubernetes as a default standard. So that way, they no need to be vendor specific here. I mean, if you go to SageMaker, it is now AWS specific, right? But if you're embracing Kubeflow, which is Kubernetes specific, which is then vendor agnostic. So you can be moving your pipelines to any cloud who supports Kubernetes. Yeah. So yeah, I think that way GCP. I see all their products. I mean, um, I spend more time now in GCP now after realizing. I mean, after knowing more about GCP, I realized that most of their products, uh, either they published papers and it become popular, and they spend time in the open source, and they took the commercial version of it into GCP. So if you take any product or most of the products in GCP, they have an equivalent. They embrace an open source product. And for example, Kubernetes, if you take the Google Kubernetes in GKE, Google Kubernetes Engine is an open source Kubernetes which was taken and embraced into GCP, and it's added a commercial flavor to it. So same thing, the same applies. Even Kubeflow is also one category, so where it is taken that way. So most of the products, I wouldn't say all, but at least the popular products, and even the big data space. If you take the big table, is again Apache HBase commercial version. Dialogflow, which you're seeing next, is Apache Airflow. Apache Airflow is a popular product for dialog for making a workflow requirement. So Dialogflow, which you're seeing the next, is an implementation of Apache workflow. So likewise, there are a lot of products which are taken from open source world. So that way you'll be more familiar with those products. Probably you should know the delta, which is added by GCP on top. So I had this one comment which I thought
Yeah.
share.
So one thing, so the Kubernetes is nothing but it's just what do you call orchestration layer, right? Like just like how Amazon is doing your virtual machines as if you own a machine, right? Kubernetes is doing it at a micro level, right? Like so, what way you are directly kind of interacting with it? I don't think you will be interacting directly with it, right? You're just going to deal with products, right?
No, when you say interacting, the architecture, right? So first of all, we never talked about the architecture of Kubernetes. There is a control plane, which is kind of what you said, like an orchestration. It's not just a regular orchestration, regular BPM orchestration. It is not that kind of a thing. It is orchestrating the worker node. The worker nodes are the one which are the real the machine behind your execution, basically. right? The thing is, so is your question is how are we directly interacting with the Kubernetes, or what is your question?
My question is, right, like, so yeah, Kubernetes is it's just like Amazon is hiding a lot of this virtual machine creation and other things. All you are doing is just, okay, I want a new server. That's it, right? Same thing, like when you have your application or when you have a product, it is like management. So in your Kubernetes environment, it is managed in the Kubernetes. I would think the cloud providers would do that for you, right?
Yeah,
From an
but
architectural perspective, when you come in, right, like what do you have to know in terms of Kubernetes? Actually, I mean,
so
is there
when
anything
you
special? Like my comparison is this, right? Like we saw that Route 53 and other things, right? Is there
yeah
anything equivalent in Kubernetes that we got to know?
no. So first of all, like what you said, one thing is correct. This coming out with the EC2 machines or the Azure machine just by a click is there for last 10 years now, or so 10 years mostly, yes. But Kubernetes now, instead of you're talking on the VM level, now you're talking on the container level. Behind the scene, see, in this, when you talk about the Kubernetes, that Docker image, right? And Kubernetes world, it is pod. The corresponding thing is equivalent of a Docker image is going to be on a pod level. Okay. And whenever you previously in the EC2 machine, you say I want to scale with auto scaling group, or even in the Azure side, auto scaling group, even in the GCP auto scaling group, which was there for last 10 years. But now what is changing is you don't talk on the VM level. Now you are talking on the container level. Now, previously when you monitor, right, you monitor on the VM, what is the CPU of the machine or what is the memory of the machine. uh, Now you don't talk on that level. Now you're talking on your container level. What should be my pod min request size? What CPU? What is the request CPU? Request limit? Okay, so now your yardstick is changed from the machine to the container. So so that there are two things. One is whenever you are trying to deploy your containers in Kubernetes, first, it's trying to auto scale. It try to auto scale your pod. You could say I want to have a 2 pod to 5 pod or 10 pod. But in case if the 10, if it has to bring the 10 pod, if the one machine cannot handle, then it will collaborate with the good old way of the auto scaling group. Still, that is not going away, but that is happening behind the scene, and it gives you the another machine also for you. But it won't start immediately in machine. It will start the pod, and if the pod saturate to a limit, then if it need, it automatically gets the new machines. You see where I'm going, right? That is the difference.
That's okay, right? Like, so what we have to know is like for all these products, right? Like, so um, when we actually like say, okay, I am going to put this product, uh, but it is mainly Kubernetes. Like, do I have to know anything? Like, I have to do anything, or is it just automatically? It's like
No,
because
no.
with the VM, it was like very complex, right?
Uh, uh,
VPC was there, everything was there. Like with
Here,
Kubernetes, you don't have to do it.
no, here you have your own lingo is there. Ingress. They also have a similar persistence volume claim. So there is a learning curve involved. Actually, there is a steeper learning curve for the Kubernetes. It is, I would say that VM layer is not that complex. Yeah, it was complex, but this has a little bit more nuances to it. But you get a lot more benefit. There's a learning curve here. You have to know the YAML. You have to know all the jargons within that to deploy anything.
Yeah, yeah, I think to answer your question, it is there are, as Srini said, a lot of jargons are there, but it is equivalent. I mean, whatever you do in VM, it is same. But just that there are Kubernetes specific terminologies that you need to be aware, and it is completely declarative language where you need to define everything yeah, what you need for your environment, you have to give it as an input in the form of a YAML file. But it is up. But most of the job is done by Kubernetes to take care of your requirement. So you just need to declaratively tell I need 3 nodes running, and my scaling capacity, like if the CPU is 80%, scale it. So that is your requirement. You just give the requirement in the form of an input, which is a YAML file, and yeah, and it is up to the Kubernetes to manage that requirement. So you don't need to give any input for it. So that is completely different from where you need to manage everything on a VM. You are responsible to scale it. You are responsible to manage from 1 node to 10 nodes. So all these things you need to manage. But the same requirement, if you have to give it to Kubernetes, it will take care. You just tell the requirement for it to take care. So that is the difference. So from I mean, this is a sample application. I just want to show you some. I just a deroute. Since the question came, I think we need to definitely take this is coming again and again. I think we should take a separate session for Kubernetes. Probably we'll spend some time there because it is coming. I think it is good to know that internals of Kubernetes better. But yeah, I think to just answer this question, let's say you have the sample from GCP that I'm taking, but it's more or less same for any Kubernetes specific vendors. Let's assume you have a Hello World app. So the prerequisites for you are from any cloud vendor is you need to create a cluster first. So cluster is nothing but a list of nodes, a list of compute, or list of VMs. So you just need to create a cluster, saying here we are creating a command using gcloud command. You are creating a cluster saying hello cluster, and so it will. If you're not giving any input, by default it creates 3 nodes in the cluster. So now if you do a list, it is giving 3 nodes. So now we have a cluster with 3 VMs inside that cluster. So now to create this cluster behind the scenes, it uses virtual machine. If you see here, it is using a machine type medium size, and the zone is US East. So in US East region, it is creating 2 or 3 virtual machines. So again, Kubernetes here behind the scenes, it is using EC2 equivalent here in Google. So it is creating a virtual machine behind the scenes. So okay, now here you saw compute is used behind Kubernetes, right? So let's go further. So you have at this point you have 3 empty virtual machines running, but you have not deployed any software yet. So now next time is now you have a Hello World app, and you want to deploy that Hello World app, and kubectl or kubectl is most popular command line for Kubernetes. Everything you talk in terms of kubectl. So kubectl, then you're telling create deployment, and you're telling deploy this app, Hello World app, and this Hello World app is in a I already stored it in as a container image in my container registry in just like it's like an artifact like Docker Hub. So you have so you already have an image uploaded, container image uploaded for Hello World app. So this is a binary basically. So you already uploaded this container image, and you are asking to deploy this image, binary image, into especially the V1 version of this image, and you are asking to deploy it. And now at the end of this command, it will deploy Kubernetes deployment for Hello World app. It deploys this Docker image onto the 3 virtual machines. Now deployment is done. Now you want to take care of scaling, so auto scaling. So you are telling I don't want one. I need three replicas running on this machine. So now again, this is one command line, simple command line scale, and you're telling replicas is equal to 3. So now 3 instances will be running on the 3 virtual machines that we created above. Right. The next is you also want to tell using Kubernetes what should be your scaling requirement, auto scaling requirement. You're telling your scale to 3, but when it should scale, what is the condition to scale? The condition to scale is whenever the CPU percentage is 80, so you have to scale, and the minimum is 1 and maximum is 5. So even though it scales Max is 5, so beyond 5 it will not scale. So max is your 5. So every time whenever it starts with minimum one instance, but when CPU reaches 80, it will scale up. So again, you are giving it. I mean, the same thing can define in YAML file. Here, it is not. It's not using YAML, but you can give the same requirement in a YAML file. But you're not giving any other input. You're just telling this is my requirement. But Kubernetes will take care of this. Okay, now, yeah, again, as Srini said, everything is pods there. So you can, after telling that the replica is 3, so when you do how many are running, your output will be 3. There will be 3 instances of Hello app running on the same virtual machine. So yeah, so that is one thing. So let's say, so this is all just deployment. And then you want to expose a load balancer to this. Okay, so because there are 3 instances are running, so a load should come at any given time to one, not all 3, right? So then you need to the load balancer requirement will come. Then how? Again, it's a Kubernetes. Kubernetes will take care of load balancer requirement also. So here you are telling balance the load again on port 80, and the target port is the Kubernetes container port is 8080. So you're telling create a deployment saying load balancer of type load balancer and manage this load. So then automatically Kubernetes will give you an external IP for this, because since you told it is type is load balancer, it will automatically create an external IP for you. So you don't need to remember all the 3 internal IPs. There will be 3 internal IPs, but you just need to remember only external IP. This is what you give to external world. HTTP 203 whatever this IP / hello world. It will take you to one of the 3 instances that is already running. So yeah, that's all. So basically, from the simplest example, again, it's lot of things are there, but in the simplest example, you saw Kubernetes is creating a compute. It is also taking care of your networking with load balancer, and it is taking care of your scaling requirements. So all are simple commands. Behind the scenes, it could be any cloud, but kubectl is one keyword you need to know. So that's all. I mean, behind the scenes, it can talk to AWS, or it can talk to Azure, or it can talk to GCP. So, but yeah, this is what you need to know at the end. So this is making cloud like vendor neutral, right? You can here it doesn't matter where it is. So you just need to remember these commands as a developer that you need to know. Yeah, that's all. Sorry, I think it's it.
So yeah, that's good actually. So this is all the Kubernetes actually management, right? Like, so what
Exactly.
I'm coming to is, right, like this is the nitty gritty of the Kubernetes thing, right? Like, so do the cloud providers like kind of do this more friendlier way, because this is like a learning curve, like somebody who's coming new.
Hmm.
Do any of the cloud providers, do they provide a kind of a wrapper
Yeah,
over this
Redshift. Say IBM bought that Red Hat, right? That is the
OpenShift?
OpenShift. So for the rest of the people, it is the kubectl way. But for the Red Hat, they have source code to Kubernetes generation S2C. So they are the only one which is taking that route. The rest of the guys, you have to know the kubectl and you have to know the jargons. You have to know the thing.
Yeah, I mean, this YAML generation is now automated more or less. You don't need to. It defaultly creates the standard YAMLs because YAML is boring, right? I mean, you need to create a lot of YAMLs for this. So that is automated. I mean, it is automated in the sense like it will give the basic standard templates. But of course, you need to do on top of this. You need to customize it for your own requirement. So yeah, so that kind of automation is done, but I think it is getting simplified now. I think they understood there is a learning curve here involved, and all the cloud providers are now encouraging trainings and are making developer friendly by integrating it inside your IDs, all the Kubernetes. I mean, now if for example in Google, Google and also in Azure, Azure, you know that VS Code is more popular, right? So the VS Code library IDE is more is getting it's one of the number one IDE nowadays because it embraces the UI developers, API developers, Node.js developers, Java developers. Everyone is nowadays using VS Code. So it's become a kind of default standard. For the Java side or dot side, especially this um, what is what is this ID? This PyCharm's ID,
IntelliJ.
IntelliJ, yeah,
IntelliJ.
IntelliJ has become de facto. So now all the this VS Code and IntelliJ are become the default to IDEs where now Kubernetes libraries were made developer friendly for developers. Basically, from the YAML syntaxes are all introduced there because I mean it's very common that you make a simple mistake in writing a YAML file. It can you'll not be able to figure out one extra space will not generate Kubernetes will fail in the YAML file. So it is very indentation and all should be careful there. So but so there are all these IDEs now Kubernetes become Kubernetes friendly and they are now made this development is become faster there. Yeah, but I think a lot of innovation is going around on this developer-friendly setup. But yeah, I think we took it route, but I think it's a good, it helps. But I think let's discuss this Kubernetes-specific setup with a live example, so that will be more clear. Yeah, probably let's come back to this flow. So this yeah, I think we're talking about this ML ops and DevOps category, and to manage this entire ML model, like starting from manage to deploy to monitor to govern. So the SageMaker pipelines and model monitor, and Azure it is ML ops, and it is GCP it is Kubeflow. Next is the category of this intelligent bots, integrating them with existing tooling. Existing tooling, in sense, your Skype, your Teams, your Twitter. So integrating the bots with your existing tooling in that category. So in AWS we have SageMaker workflows, because though we're talking about workflow. If this condition, put it to Teams, or if there's a build failure, put it in your Teams channel. So like this. So there are a lot of use cases which are now very connected with the workflows. So for that use cases, I think yeah, these toolings are there. So AWS SageMaker workflows and AWS model pipelines will give you that connectivity to all the popular products. In Azure, it is bot framework, and in GCP, it is Dialogflow. So again, as I said, Dialogflow is the equivalent open source is Apache Workflow, so Airflow, sorry, Apache Airflow. And here in this next is the category of virtual assistant template to bring together the best practices. So yeah, I think there are a lot of innovation happening in this space, and it is there's a place where templates can be introduced, where if there's a common problem, there's a template for everything. So instead of reinventing the wheel, you can use a template and customize the template for incremental customization you can do, but most of the job is already there done. So for that kind of templating requirements and following the best practices with templates, AWS has a tool called Skillset, AWS Skillset, sorry, SkillsKit, sorry, SkillsKit, because it's again coming back to the Echo category. So we saw the Alexa Skills Kit. So there's a SkillsKit template is also there. SkillsKit is primarily to help you to manage these templates. And in Azure it is virtual assistant, and in GCP it is Dialogflow templates. So and next is the open source ML framework, and most of the tools, all the cloud vendors, they picked one or the other tooling or framework, ML framework, open source ML framework. For example, AWS picked MXNet and PyTorch. Azure picked ML.NET, and GCP picked TensorFlow. So again, all of them are popular. And again, the most popular are TensorFlow, MXNet, PyTorch. So So yeah, these three are getting a lot of traction. Again, in fact, PyTorch is getting a lot of traction. TensorFlow is a steep learning curve, but PyTorch is from Facebook. Yeah, so it is also getting a lot of traction now. MXNet is from Apache. Uh, and this, yeah, next is open format to building ML models, because ML models, every company is generating ML model these days. So, so there's an open format that has come so that, to standardize the ML models. So that category of standardizing the ML models using some open format. Um, so there's a consortium of a lot of companies together coming to come up with an open format template for ML models. In that category, AWS open source open format template ONNX, which is Open Neural Network Exchange. And Azure also follows the same thing. Even Azure, Microsoft and us, AWS have come together for ONNX. Of course, GCP it is TensorFlow format, open format. So yeah. So there's some lot of open work is being developed, and open source frameworks are heavily used in this space. But yeah, again, it is very diverse. So some consolidation is required. I think now, yeah, industry is going towards that consolidation phase. But still, a lot of innovation is happening. So every day a new library or new framework is coming. So yeah, I think every day Python there is a new library also is coming in this ML category. So yeah, I think it is difficult to keep up to date, but it is very very important to keep up to date in this space. Yes, so that's about the AI ML category. Probably the next one is IoT. I think logically with this we will close this comparison study. IoT is very diversified area like AML. I mean, generally, I work in this IoT space heavily. At least in the last 1.5 years, I'm in this IoT space. This area is growing very fast, but at the same time, because of a lot of frameworks are there, it is also going slow. I mean, it's a contradictory statement, but I think it is true in sense. A lot of new protocols are coming in this space, which is dominating the previous one. So that way, there's no consolidation is not happening yet. So because of which, many companies they see there's a value in this, but at the same time, what is done today within 6 months it is getting outdated. So that is one of the problem statement in this space. But still, I think it is there's a lot of competition also is there. So I think and a lot of um, it is one of the area where it can touch a common man. So because from starting from wearables or to the smartphones to the devices that he uses on a day-to-day, starting from machines that he uses on a day-to-day like fridge to refrigerators to air coolers to so you said it will that touching your common man. So that way you get a lot of data in this space, and the data that is coming is so huge. So you need a cloud in this space because the data that you get, you can get this done in on-premise world, but still the data is huge. It is good to rely on a cloud provider. So yeah, so coming into that space is IoT framework, which is like again a flagship product. So all the sub products come under this flagship product. So which is AWS IoT is a flagship product, and Azure it is Azure IoT Hub, and GCP it is Cloud IoT Core. So these are flagship products, and under that, the one which I marked in bold here, these are the categories which I see, so that way it is easier to understand the categories. So the device software. The device software is like it is like a compute or a microcontroller category where which is very important because the devices that the IoT devices, it varies from in size to compute. because there could be small chips where it not even have memory to store anything. So to a Raspberry Pi or a credit card level size computer device where it can store barely some data. So yeah, every device is not same, and every device follows a different protocol. So in this category, um, especially for devices where you can have some storage and compute inbuilt, so which means you can install something on those devices. So in that category, where you can install some device software, it is not a hardware. I mean, it's like a device software. It's like a it's like a hardware come software together. So they call it firmware to be specific. It's a firmware that you need to install on the low compute devices. So in this category of device softwares, AWS has AWS IoT Greengrass, um, and Azure it is IoT Edge, and GCP it is Edge TPU. So most of these devices which hold this device software, it is very important because all these device softwares, they understand cloud, meaning whenever data comes to these devices, they know that they have to send it to the respective cloud. So, but this device will not have a lot of compute or memory space because and they'll be on field. Uh, so a lot of other distractions and the network and all this because all these devices are on field. So all these will have limited compute category, limited compute space, and they also can as long as this device also have some softwares that you can install, then yeah, these are the softwares that respective cloud vendors they're providing. So these softwares you need to install on those devices, so that way they can understand the cloud language. So meaning whenever you get a data, so it can this is called in the edge devices. In the edge devices you can install the softwares. For example, let's say you have machine learning output. So uh, you want to install this machine learning output on the device so it can make intelligent decisions next time. So then you need to install the softwares on the or machine learning output on this edge devices, so that whenever new data comes, it can apply this machine learning output on the data, and it can make a decision whether this data is worth sending to cloud or not. So that intelligent decisions are made. The older before this edge category came, what happens is every data that you get was pushed to cloud, but it's very costly, right? I mean, pushing over the network is to cloud is huge. So but you can filter a lot of data which you don't need. Let's say you're interested in, let's say, a temperature sensor, where you're interested to know if the temperature value is above 50 degrees centigrade. You're interested only in that data. So you can apply that logic onto this devices, and it can send only the readings which are greater than 50 degrees centigrade. So that intelligence is you're adding it to the device. So yeah, so to deploy or manage these devices like that, like edge devices, so you need to have a software that is what this category is, so like IoT Greengrass, IoT Edge, and Edge TPU. And next is the microcontrollers. Some of the devices has compute, but there will be some devices which are very minute. So for entire maximum, it can have 5 MB of space. So in that you can't install softwares like heavy softwares like the previous category. So 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 there are small chips. So in that category, you need a OS, let's say, to install. So to install a tiny OS on a microcontroller, so it can do things more intelligently. So in that category, there are a lot of OS microcontroller operating systems were introduced. All these operating systems, especially the RTOS software, is a very popular open source operating system software, and this is RTOS software is installed on generally on very smaller devices. So the entire operating system size is 10 MB, or sometimes even now they're trying to even reduce it further. Yeah. So so yeah, AWS took that open source software and they came with the AWS version, which is free RTOS. Azure has Azure RTOS, and I don't see anything equivalent in GCP yet. Again, next is the device softwares that we saw, either microcontrollers or compute, tiny compute. Next is connectivity. So how will you connect these devices to cloud? So in that space, um, so IoT core, AWS IoT core. I didn't see anything equivalent here, but in GCP it is cloud IoT core. And then next is once let's say you're getting data, but you want to monitor the data and see the security aspect and auditing aspect and other things, because they're already sending data to you, and now you want to manage or monitor this kind of a day two problem. So how will you handle the security in this? So especially, so this IoT space is a very common area where it can it can go flop on security. Security loopholes are very common in IoT device because they they don't have a lot of memory or bandwidth. Like it's not a computer or laptop. It's not having such huge compute or memory. So it can. But if you're bringing the device online, which means you're making the device on an attack surface. So to handle that security aspect, so a lot of tools are around security, IoT security space, which is in AWS is IoT Device Defender. In Azure, it is Azure Sphere. I don't think anything equivalent in GCP here. So Azure Sphere is one of the recent introduction of a security aspect, especially for IoT devices and microcontrollers. Azure in the last year, Microsoft is ready to spend, or it is publicly announced that they are planning to spend 5 billion USD on this IoT area. So, and one of the areas where they are spending more is security. So, yeah, Azure Sphere is one innovation in that space of IoT security. Next is the device management. This is the area where I am working. So the device management is this is very this is managing the device, meaning all these IoT devices you need to onboard them into your system. So first, the device management process is like you have to first onboard these devices, activate the devices, and then publish data to the devices or read data from the devices, and then restart the devices, or also you can push some data to the device or get the data from the device. These are very common patterns. Like for example, you can control a device remotely sitting in an office. You can control a device sitting somewhere in forest or in a desert. So you can control the device remotely. So the remote device management is where the intelligence lies, and for that you need to understand various protocols. This device management software, it needs to understand various protocols because each device is unique and each device follows specific protocols. By default, not HTTP is not the default protocol. HTTP will not suit for IoT. So there are a lot of protocols like MQTT, protocols like LWMTM, or protocols like ZigBee, Wi-Fi. So various other protocols are there. So there are quite a few protocols are there. So so as I said, like each device is unique. So this device management software should understand all these protocols. And when it's onboarding a device into the platform, a device management software, it should associate, it should understand that language or protocol, and it should communicate to the device. So I mean, whenever you say start the device or stop the device, you're giving the control to the device, and internally this device management software is translating that control to a language that device understands. So and it depends on the protocol. So yeah, so that is what this device management area is. So you need to understand various protocols, how they work, and and how to control a device. These are the various areas that you need to understand this better. So in this category, IoT device management, and next is Azure device management. Then here it is Cloud IoT Core Device Manager. Then next is now you got the data from
So
this.
so
Yeah.
so on your company, what device management things you guys are using?
Yeah, especially my company is it's Ericsson, which is it is primarily into telecom side. So telecom area is where we are focused. And this telecom domain, there are specific protocols which work on SIM. SIM is, the SIM card that you use in a mobile. So it provides 3G, 4G, 5G, which is the signal to get the internet. So we work on the SIM-based IoT devices. Any devices which can hold SIM, like your mobile, is one use case. But likewise, there are a lot of IoT devices which can accept SIM. For example, you can take protocols like smart water heater, smart data generator, or smart water pipeline settings or water treatment settings. So all these things, they need to push the data over internet, and for that one medium is to use cellular IoT. So yeah, we work on a cellular IoT space, very specific. The cellular IoT space has cellular specific protocols, which is lightweight machine to machine, is LWM term, which is one of the very common protocol in this cellular IoT space, LWM term, lightweight machine to machine. And we also work on a protocol called NADD. So this is non-IP data delivery. So which is again a protocol which works on cellular towers, where the cellular towers will have a radioactive signal, which will especially, it is okay in the cities. It is the cities, the cellular towers are easy to manage because a person can go and fix if there is any problem. But imagine the tower is in a place where it is not accessible by human very easily. Let's say in mountains or deep forests. So there, the battery power is very important for such devices, cellular towers. It's very interesting use case. So to manage a cellular device in such a remote place, you want to control that software, and especially optimize the battery power on that. It it requires a separate protocol called non-IP data delivery, NADD. So as per this protocol, the device will sleep most of the time, just to save power. And as and when there is a radioactive signal that comes there, it will wake up, and it will transmit the data over the network, or 4G or 5G. So that activating on a radioactive signal, which is a innovation. So that concept is what we work on the protocol in that space. Yeah, so these are all again cellular IoT specific protocols, but
So
but
this silver IoT, is it integrate? Can it be integrated to any of the cloud things?
yeah, all this device management category, this is this set of tools in this bucket. They support cellular IoT protocols also, because all these cloud vendors now they are targeting telecom vendors, because telecom has a lot of data, and the 5G now coming, a lot of traction on 5G, because 5G can send a lot of data with on a lesser bandwidth also. So, and that is very very important for IoT. So yeah, so 5G, telecom, and telecom specific protocols is where I am working on, and this device management software, um, they have a separate subdivision for that category. But cellular IoT is
So
one smaller area out of the bigger pie. So what we work is just cellular IoT, but there is other area, a bigger pie is industrial IoT. So industrial IoT is also very popular because I mean in as you know, industrial IoT is a superpower because a lot of industries are there, and industry IoT specific protocols are different. So, so likewise, every industry has specific IoT protocols which suit. So yeah, it depends on the area. That's why I said this IoT space is very dispersed, and a lot of protocols are there, which is again specific to specific industries.
So
So
where are you storing your data currently? Which cloud? Is it cloud or on-premise?
it is
From all
on-premise.
these.
In our case, it is on-premise. Ericsson has at least their own on data center storage, but in this process, uh, they have their own data center and they provide this device management software for cellular IoT space. So
Yeah, but is there is a roadmap for tying with any of the cloud stuff because they have to scale, right?
yeah, correct. I think they're tying up with Azure. So Azure and AWS also is in West. So this Azure is the first pilot that they are doing. So they are actually tying up with. I mean, the this is when it says cellular IoT, we also need to interact with the cellular provider. For example, uh, T-Mobile or anything. In India, is Airtel or Vodafone or whatever. So you need to tie up with your telecom provider, and because they provide the data or internet, right? And we provide them the software to manage that device, and they are using our software to manage their SIM cards. Um, and we also deal with hardware where the telecom towers and management of the hardwares for telecom is also outsourced to a lot of vendors. Like Ericsson is one such vendor. So yeah, it depends on. So it's not just one person's job there. So it is coming together with a telecom operator, telecom provider, and also the cloud provider. So all three together coming there. Yeah.
Yeah. So one suggestion for you is since you are already on this space, if you focus on the Azure side of the space, I think there are not very many people available. See, in AWS, it is there for some time. There are some competition there. In Azure IoT slash big data, that is where I think the traction is happening now.
Yeah, exactly. I think with the innovation where I mean Azure Microsoft is planning to spend a lot on innovation on this IoT space. I think now yeah, I think a lot of investments are going on this IoT space. So yes, yeah, definitely. Yeah, I think let's continue further. I think we have one more slide. This is all connectivity and device management. The next one is now we have the data coming. Then now you have to manage, take care of the analytics. So, so run analytics on the volumes of IoT data. So it is not easy because you're talking about volumes of data now. So the running analytics on it is you need to specialize softwares, which is AWS IoT, AWS IoT Analytics, and Azure, I didn't find anything specific to IoT because it is data stacks and HT Insight is anyway the big data side of architecture. So that is what is being used. But here it is IoT specific analytics was introduced here. Again here BigQuery. This is also something IoT specific, but again any big data solution software. So GCP is BigQuery. Um, then again, this one is specific to AWS because I didn't find anything equivalents in this space. This is a category where uh, managing your industrial data. So industrial data will have, if you take any industry, there are a lot of devices will be there in the industry. It takes starting from manufacturing plant. If you take, there'll be so many devices in the manufacturing plant, starting from, let's say, it depends on the plant, but boilerplate, the boiler. If you take, there will be so many devices to measure temperatures at various points. Or if you take the pipeline of so it will have a lot of devices to monitor the quality of the output that is coming from the pipeline. So yeah, it depends on industry, but it is very difficult to manage, collect and organize or analyze the data that is coming from particular industrial data that is coming out from a site. So to manage that particular site in a better way, so IoT, AWS has a solution called IoT Sitewise. So basically, Sitewise will manage the device from a particular site. So it is more of organizing the devices in a better way. So again, this is a subset for me. For me, this looks a subset under device management because you need to manage the devices inside a particular region. For me, the region here is an industrial area or industrial site. So yeah, so that's why probably this identified anything equivalent here, but I think this is more or less embedded in this category. Yeah. And the last one is again the analytics category, where you need to connect different devices to build IoT applications. So in uh, this digital twin, or which is again very getting a lot of popularity, the digital twin uh, is is like simulator of the actual device. You can think that way. So in most of the problems in IoT, it is difficult to apply the data on a real device because it's just like a mobile, right? So mobile, you can't have so many versions of mobile because Android as itself has so many versions, and similarly iOS also has so many versions, and each vendor is buying starting from LG to Samsung to so many companies have different variations to it. So it is impossible to apply your software how it is working on a mobile, right? So it's the same problem in IoT also. So many vendors who produce, generate this, create, manufacture this IoT devices, and each is different. So to check whether the software is working or not, so they use a lot of simulators. Just like mobile simulator, there's an IoT simulator also there. So IoT simulator is what is called digital twin. Again, the term is now kind of standardized. Digital twin is just from the name itself. It's a twin of your a replica of your device, not the actual, but it's a replica. So generally, instead of applying your data on the actual, they will apply it on replica and see or simulator see how it performs, and then once they get a good result, then they will apply it on the actual device, just like a flight simulator equivalent. So yeah, so in that category, it is IoT. In AWS is IoT things graph. In Azure it is Azure digital twins. I didn't find anything equivalent in GCP yet. Again, next is an analytics category. You get a lot of data, which is in the form of an event. So you need to detect and respond to the events from IoT devices. Again, it is coming under the messaging category. So it's just like Kafka equivalent. So you get a lot of data or events, and you need to manage that. So in AWS, it is AWS IoT events. In Azure, it is Azure Event Hubs or Stream Analytics or HT Insight Kafka. So and in GCP, it is Cloud Pops Up, publisher subscriber. So an event that is coming. So publisher will publish the data, and there will be subscriber who will subscribe to the data, and he will automatically receive that event. So yeah, so this is also very popular. So yeah, this is the tools around that. So in summary, in what I see is that AWS is in this IoT space. AWS has wide set of tools compared to Azure, and Azure is catching up for sure. GCP is a lot more to catch up in this space. So yeah, but I think probably a matter of time. So I think this area also will catch up. But AWS is definitely leading in this IoT space. Yes, I think that's all I have for today. I think we also budgetly time up. So probably in the next section we will go. I think we're done with all this analysis of various products in various space in various areas. Actually, we saw. But yeah, I think let's go deep dive into GCP now. Yeah, that's all I have. So anything else?
It was great detail, Shyam. Thank you.
Yeah, welcome.
Yeah, Shyam. Shyam,
Yeah,
next
thanks,
week.
man. Yeah, it was too deep, but it's very good.
Yeah.
Right. Definitely,
Okay.
it gives a good picture. Yeah. Thanks.
Yeah, I think it. I didn't find all. I mean, this is not. I spent a lot of time on this to get this data. It is not obvious. I mean, I had to look at, understand these products. I've not worked on this products yet, but I think it is not easy to consolidate. I don't see much data in internet also, especially in the IoT space. So, but yeah, I think it is. This comparison gives me a perspective of how to see all these cloud providers. And from what I see, I think all three are neck to neck, especially yeah, and especially in the IoT space. But I see GCP is compared, even though it came late. I think it is competing with AWS and Azure equally. So all the core pillars are covered, and just now it is going to specialization now. So yeah.
Yeah, cloud with IoT is a good combination now.
Yeah, exactly. Yeah, Venkat, you're telling
Okay, man.
something.
Yeah. Yeah, sorry.
Okay. So
Venkat, you have something?
Next week you told that so you're going to take that Kubernetes, the basis, or we are going to jump into the GCP.
Yeah, I think that's a good question. So, what do you guys think? Is it I can do both? Probably. Do you think Kubernetes is logical point? Then I can start Kubernetes and then move to GCP also. What is the preference?
Yeah, but don't go too deep dive. That will be boring. Keep it little shallow, so that everybody understands, right? You get a diverse group, right?
Yeah, sure. Yeah, I agree.
Okay.
Yeah,
Yeah, so
probably I will
probably you can
spend.
take off. Yeah, 50% here, 50% there, something like that.
Yeah, sure. Yeah, sure. I will probably spend some time with Kubernetes next week. And then probably go deep dive into GCP later.
Yeah.
yeah, that would be a good segue for this Kubernetes.
Yeah. The Segway has become so popular now. I mean, especially this
Yeah.
Kubernetes area is a lot of segues in Kubernetes area. Yeah. Okay. Good. Yeah. Thank you.
Great.
Okay. See you. Bye.
Bye
Yeah.
bye.
But
Thank you, everyone. Thanks.
Thanks, man.
Thank you.